ECE 41 Communications for Transmission Media and Antenna System and Design. Hello, I am Jessa Florence M. Gallus, a BS ECE 3A student of Iloilo Science and Technology University. So we have an activity and it is based on our first name, middle name, and last name initial letters. We will choose 3 types of antennas based on the attached list of antennas. So I have already chosen the type of antenna regarding with my initials. J is for the slot antenna, M is for the Cassegrain Reflector antenna, and G for the Waveguide. Waveguide is not an antenna. J for slot antenna. So a slot antenna, consisting of a narrow slit in a ground plane, is a very versatile antenna. Consists of metal surface, usually a flat plate with 1 or more holes or slots cut out. It operates at 300 MHz to 30 GHz. It is a type of antenna with an opening cut of certain dimensions in a metallic conductor which is excited using a 2-wire transmission line or coaxial cable is known as a slot antenna. How it operates. Slot antennas operate on the principle that whenever a high-frequency field is present across the slot in a metallic sheet, then energy is radiated. The slot antenna follows Babinet's principle. Babinet's proposed that 2 complementary screens generate a similar diffraction pattern. This is known as Babinet's principle. According to this principle, the structure of the slot antenna and the half-wave dipole structure cut out from the conducting sheet are complementary to each other. This is the reason when a slot is cut from the surface of the conductive plate then, on energizing the slot, the electromagnetic wave is radiated, thus acts as an antenna. Due to the presence of a slot, it is named as slot antenna. Thus, we can say a conductive surface with a slot of particular dimension is referred as slot antenna. Applications. Standard laboratory microwave sources used for research. UHF television transmitting antennas. Antennas on missiles and aircrafts. Sectors antennas for cellular base stations, particularly marine radar antennas. So this crossband slotted waveguide marine radar antenna on ship is an 8 to 12 GHz. The antenna radiates a narrow vertical fan-shaped beam of microwaves scanning the entire 360 degrees water surface around the ship with each rotation. To know the impedance of slot antenna, the relationship between the terminal impedance of slot Z and dipole ZD is given as Zs times Zd is equals to 1/4 times quantity N0 squared. N0 denotes the intrinsic impedance of free space. So since N0 is equals to 376.7 ohms, thus on substituting we will get 35,475.7225 ohms. Hence, Zs is equals to 35,476 over Zd ohms. Therefore, we can determine the properties of the complementary slot antenna if the properties of the dipole antenna are known. For a half-wave dipole antenna, Zd is equals to 73 plus J 42.5 ohms. Then Zs will simply be 363 minus J 211 ohms. Next is the Cassegrain Reflector antenna. A Cassegrain reflector antenna is a system that composed of double reflecting mirrors and used in communication systems working in the millimeter wave range. It is consists of a parabolic reflector, a primary feed subreflector, and a feed support assembly of 4 low-profile aluminum spars that are attached to the rim of the reflector to position the feed. Their high amplification factor and narrow directional pattern of Cassegrain antennas are used in wireless communication systems of peer-to-peer type. The highlights of a Cassegrain reflector antenna is it has low VSWR, aluminum construction, fiberglass, and has a high performance at millimeter wave frequencies. Its application is in radar, telemetry systems, and point-to-point communication system. Now let's move on to letter G, waveguide. This type of waveguide is used as transmission line mostly at microwave frequencies for such purposes as connecting microwave transmitters and receivers to their antennas in equipment such as microwave ovens, radar sets, satellite communications, and microwave radio links. Waveguide is a hollow metal pipe used to carry radio waves. The electromagnetic waves in a metal pipe waveguide may be imagined as traveling down the guide in a zigzag path, being repeatedly reflected between opposite walls of the guide. It can be rectangular or circular, made of brass, copper, or aluminum. So these are the collection of waveguide components. The uses of waveguides. The uses of waveguides for transmitting signals were known even before the term was coined. The phenomenon of sound waves guide through a taut wire have been known for a long time, as well as sound through a hollow pipe such as a cave or medical stethoscope. Other uses of waveguides are in transmitting power between the components of a system such as radio, radar, or optical devices. Waveguides are the fundamental principle of guided wave testing, or GWT, one of the many methods of non-destructive evaluation. First use is the optical fibers. It transmits light and signals for long distances with low attenuation and a wide usable range of wavelength. Next, in a microwave oven, a waveguide transfers power from the magnetron, where waves are formed, to the cooking chamber. In a radar, a waveguide transfers radio frequency energy to and from the antenna, where the impedance needs to be matched for efficient power transmission. The rectangular and circular waveguides are commonly used to connect feeds of parabolic dishes to their electronics, either low-noise receivers or power amplifiers transmitters. Waveguides are used in scientific instruments to measure optical, acoustic, and elastic properties of materials and objects. Transmission lines are a specific type of waveguide. Thank you for watching. This is Jessa Florence M. Gales, BSECE student. Bye-bye.